Welcome everybody to what is our last video for this pre-calculus course. This one is devoted to logarithms one more time, and in this video we shall study properties of logs. Before we actually get started, a quick recall. The fundamental connection between logs and exponential is important, so we will say that if log base a of y equals to x, this shall be the same. This shall be the same as what? Remember the little way we had previous videos? This to the power of that is equal to this. So it's the same as y equals a to the x. Out of this, I would like to consider, say, the following function. Call it example 1, 2.5 stars. Let's consider what 5 to the power of log base 5 of 3. Suppose I have an expression like this. How can we change it? Write it. It can be written. It can be written as. Now, what I have here is something that actually is similar to this guy here, a to the x, right? A to the x. Consider a as the 5 and consider x as the log of 3 base 5. So let y equals 5 to the log of 3 base 5, so that I have something like this. Let us turn that into a log. So remember that a is 5 and x, the exponent, is this entire thing. This is my x. You following this? Okay, so I'm going to write this as that, meaning that this is the same as what? Can we turn it? Log to the base 5 of y is equal to my exponent x log to the base 5 of 3. Yeah? So comparing log of y with log of 3, both base 5, it's like I could cancel the logs, right, in a certain way. Log of something equals log of something. The inside of the logs, which are here and here, should be the same. So it follows that y is equal to 3, and y was what? Y was this guy, 5 to the power of log base 5 of 3. And we find out that this is equal to 3. That is the first little property or rule of this lecture today, because it actually says the following. If you have 5 to a power of log 5 something, the inside of the log is going to be always the answer to this. So let's make this a rule. So conclusion. If you have a to the power of log a of x, then you will actually be able to write this as x, provided of course that my a is positive. We've seen y in the previous video because of the graph of ln, and this is my first property, if you want. Okay, so a to the power of log, as long as the base of this log is the same as the base of this exponential, then the inside of the log is the answer, always. Good. We might actually be called upon using this later on. All right. So let us actually take a look at three properties of logs. The first one, the log of u times v. There's a property that actually allows us to break the log of a product in the following way. This is going to be the log of u plus the log of v. So one log turns into two logs. Well, the product of the inside of this log turns out to be the sum of two different logs. Second property, the log of u divided by v. So some of you are clever. You can see that if multiplication turns into a plus, the division is going to probably turn into what? Yeah, you probably guessed it. A minus. So the log of a division is a subtraction of the logs. And finally, another important one, log of u, this time to the power of v. So let's say a function to a power of a function. Nice property that allows us to take the v in front of the log of u. So these are the three main properties that actually are saying log of a product, sum of the logs. Log of a quotient, difference of the logs. Log of an exponent, exponent can come in front of the logs. Let's see if we can apply that onto examples. All right. All right. Alors, exemple 2. 2.5 stars. Rewrite, I have some examples here. Rewrite log of x3 times x plus 1 over x minus 4 squared using several logs. So if you want, this is the log of all this. I will consider the top to be my u. I will consider the bottom to be my v. And I will consider this whole thing as log of u over v. And that's the second property of logs. So I will say that this is equal to the log of the top, x3 x plus 1, minus, right, log of u over v is log of u minus log of v. So x minus 4 to the power of 2. Now what? Put that over here. I don't need it anymore. Now this is a times. Yes? So this times can turn into property number 1. Log of this time is my u. This time it's my v. Log of u times v is going to be the log of u plus the log of v minus the log of x minus 4 to the 2. Can I do anything else to simplify this? Yes, I can. An exponent to the x and an exponent to the bracket, property number 3. This can actually be written as bring the power in front of the log. This is 3 log x. The second term here, I can't do much about it. Log of x plus 1. And the third term, I can take the 2 and bring it in front of the log. And I've successfully turned this one log into a sum and difference of several logs. You might think, why take a concise expression like this and spread it all out like this? The reason is, in calculus, this expression is actually easier to perform some calculus-based operation than the original one. So that's an example of the properties of logs at work. Let's do another one. Okay, exemple 2. Is this a little more difficult? Well, perhaps. Let's give it 3 stars. Same question. So write using several logs for, what do I have here? ln of the root of x squared plus y squared over x times y. Okay, yeah, that is 3 stars, I believe. So, what is this equal to? ln of the root of x squared plus y squared over xy. What can I do to this? Well, the ln of a square root, how else can I write the square root? It's the power of 1/2. So I can say this is the ln of the entire inside, but replace the square root with the power 1/2. I will have this over xy. Property number 3 of logs. I can actually take the exponent, bring it in front of the ln. So 1/2 ln of x2 plus y2 over xy. That bracket extends a little deeper. Now what's this? This is the ln of u over v, right? So my u is x squared plus y squared, my v is xy. So I can totally write this as 1/2, big bracket because the 1/2 will affect everything. The ln of the top, x2 plus y2. And then it's a division, so it's a minus the ln of xy. And now I have one last chance to use a property. It lies right here because I have a times between x and y. Uh-oh, I have a plus between x squared and y squared. Is there a property for the ln of u plus v? That cannot be broken. Only product and divisions. That is a sum? Cannot be broken. This is there to stay. So this is 1/2 ln of x squared plus y squared minus, this is the product, so let me open another bracket here, ln of x plus ln of y. And if I wanted to simplify this just a tad, it would make sense to bring the minus in front of this bracket, and the final answer to this would be 1/2 big bracket ln of x squared plus y squared, which cannot be changed. And then I would distribute the minus into the bracket, so minus ln x minus ln y. And that will be my final answer. I don't know if this is worth 3 stars. You be the judge. All right, on to something else. Okay. Example, this is example 4. 2.5 stars. And my example 4 is the opposite of what we just did. Instead of like expanding something that has 1 log, now I'm going to give you several logs, and I'm going to ask you to bring them down into 1 single log, just for practice. Right. That's a W. I don't know what it looks like. Looks like a character from a foreign language. Right. 1/2 log base 4 of 5 minus 2 log base 4 of x minus 5 log base 4 of y. Write all this as one single log expression. Okay, so this time I have the expression written all out. I want to bring it back into one single log. So 1/2 log base 4 of 5 minus 2 log base 4 of x minus 5 log base 4 of y. What is that equal to? What could we do? Let's work backwards. Starting with property number 3. If I have something in front of the log, it can actually be same as an exponent. Something in front of the log, exponent. Something in front of the log, exponent. So that would be what? Log base 4 of 5 to the 1/2. I brought what's in front as a power of 5. I'll do the same for log base 4 of x. The 2 in front becomes the exponent of x. I'll do something with log base 4 of y. That's y to the 5. Good? Okay. So now I have log of something minus something. Why don't we focus our attention on the first two terms? Let's ignore the last one for now. Log of something minus log of something. Does that remind you of something? Well, it's a subtraction. Property 2, subtraction is division. So that means that this is log base 4 of 5 to the 1/2 over x2. Agreed? Minus log to the base 4 of y5. And here's another minus. So that means that I should have equal signs here. That means that this is another division. So this is log to the base 4 of 5 to the 1/2 over x squared, all over, because it's a minus, it's a division, y to the 5. Good. Now, division, division, I'm going to simplify this just a tad and write this as log to the base 4 of 5 to the 1/2. Can I write this otherwise? What's 5 to the 1/2 if not root 5? So root 5 over x squared, and this is divided by y to the 5. Division by y to the 5 is the same as multiplication 1 over y to the 5, right? Division by y5, multiplication by the reciprocal. We've seen that before. So final answer, I can regroup this together, and the final answer for this will be log base 4 of root 5 over x squared y5. And that's really just the new expression that actually corresponds to all of these guys over there. All right, good. So practicing our rules of logs again. Okay, good. One last thing that I would like to talk to you about is the solving of equations. So new heading, solving equations. That would involve logs, of course. Solving equations. Okay, now I have here a couple of examples. We are down to example 5, I believe. Example 5, 2.5 stars. Solve and check the following equation. Log base 2 of 4x minus 3 is equal to 5. Solve and check this expression. Okay, well, we are trying to solve for x. Basically, it goes without saying. When it says solve for x. So I got a log expression. I need to free the x that's inside the log. The best thing to do here is to transform this into an exponential. So log base 2 of 4x minus 3 equals 5 is the same as what? Remember the mnemonic? 2 to the 5. So 2 to the 5 equals to the inside of the log 4x minus 3. Okay, so that's 32 is equal to 4x minus 3. Bring the minus 3 over, it becomes plus 3. So 35 is equal to 4x. And 35 over 4 is equal to x. Quick check. Quick check. I have no choice here. It says solve and check. So I have to do the check. It's not optional. So I'm going to replace my answer, 35 over 4, into here. Log base 2 of 4 times 35 over 4 minus 3. What is that? This is log base 2 of 4 and 4 cancel out. That's 35, isn't it? 4 and 4 cancel out. All I am left is 35. 35 minus 3 is 32. What is that? This is log to the base 2 of 2 to the power of 5. Yep. This is 5 in front. This is property number 3. Log of 2 to the 2, log base 2 of 2, and the 5 comes in front of the log. And you may remember that this is equal to 1. So check, because 5 times 1 is 5, the right-hand side of my expression. Easy enough, yes? Easy enough. Okay, example 6. Example 6. Example 6, what do I have? Solve log base what? Base nothing. So log x plus log of, what do we say here? 2x minus 1 is equal to 1. Check your answer. Check your answers, potentially with an S. Yes. Okay. Well, what do we have here? Log of x plus log of 2x minus 1. One of the properties of logs we just saw is that if there's a plus between logs, that can be brought together as one log. So, log of x plus log of 2x minus 1 equals 1 is the same as log of x times 2x minus 1 equals 1. Okay. All right, so that's basically what? If there is no base to the log, we all know it's base 10. So let's change this to an exponential. 10 to the power of 1 is equal to the inside of the log, x times 2x minus 1. Well, that means that 10 is equal to 2x squared minus x. Well, a quadratic equation, an x squared. So let's bring everything to one side. We know how to solve this. 2x squared minus x minus 10. And now you have options. You can actually use the quadratic formula, or you can try to factor. And the factoring here, I believe, is what? 0 equals, we should try to factor this relatively quickly. So 2x and x, I would go 5 and 2. And then I would go plus and minus. Let me check this. Minus 1, it all works. And that actually gives me what? It's going to give me two answers because I have two brackets. So either 2x minus 5 equals to 0, or x plus 2 is equal to 0. This here means 2x equals 5, so x equals 5 over 2. And the other one is minus 2. I seem to have two answers to this problem. But if you remember, it says solve and check your answer. So we should check each of these answers, which we will do over where? Over here. Okay. Those whiteboards are so small. We have to cram a little bit here. So check. So let us check minus 2. X equals minus 2. I'm going to replace x equals minus 2, where, of course, inside my original statement. So I'm going to have log of, what? Log of x is log of minus 2. Does that exist? Log of a negative number? Does not exist. I can stop right here. Stop. X equals minus 2 is not an answer. It's rejected. Injected. And the other answer, x is equal to 5 over 2. I put it in here, so I'll get log of 5 over 2 minus the log of 5 over 2 times 2 minus 1. And I should have that equal to 1. I will actually let you put the numbers into the calculator. So log of 2.5 minus the log of 4, and you will actually see that you get 1. It does check. Accepted. So the final answer to this is that x is equal to 5 over 2. And that's that. Okay, one last. One last example. We will do this example 7. Perhaps we can call this 3 stars. You'll be the judge. This is a word problem. How long will it take? How long will it take? For money, how long will it take for money to double itself? How long will it take for money to double itself? At 6% annual continuous interest. How long will it take for money to double itself at annual interest of 6%? Now, that means that we need to recall the formula that we had for continuous interest. Do you remember that? Recall A equals P E to the RT. That's the formula we use for compound interest. In this problem, we seem to be given extremely little information. The only thing given is the rate. given R is equal to 0.06. Nothing else is given. So I seem to be lacking a lot of information to answer this, right? So how long means how much time will go by. I don't have A, I don't have P. But I know that money has to double itself, right? So maybe I can make up numbers such that money has doubled itself. Say P is $1,000. For $1,000 to double itself, it will actually become how much? 2,000, obviously. So let's put this into our formula. A is equal to P, e to the RT. So A, 2,000, is equal to 1,000, that's P, e to the RT. Now you see, we're going to divide both sides by 1,000. If I had put here like 500, then that would be 250. If I put here 1,000,000, then that would be 500,000. It's always like it doubles itself. So when I divide both sides by 1,000, I will always get 2. So e to the 0.06t. So like we said, 2 is this, 0.06t. Good. Okay, so that's very nice. Let us take the ln on both sides. Ln of e to the 0.06t. That means that ln2 is equal to, remember that property number 3 of logs? I can take the exponent and bring it in front of the log. Now, ln e is log base e of e. Log base e of e. When the base is the same as the inside, it's equal to 1. So ln of 2 is equal to 0.06t times 1. So what's t? T is ln of 2 divided by 0.06. And that is approximately equal to 11.6 years. So this is how long money would take to double itself at 6%. Good. That was the last example on this chapter, and that is the last example of the last video of this course. I hope that those videos have been useful, and I wish you good luck on your future evaluations, including our exam in this course. Take care. I'll see you in class. Bye.